Hello everyone, how's it going? My name is Dan the Tutor. Today we're going to look at another question from the AP Test Free Response section. This is question 5 from 2015 for the Calc AB exam. And the reason why we're choosing this question is because I wanted to look at some questions that involve graphs of derivatives or integrals and the relationship between all of those things. So we see here that we're given the graph of f prime. Immediately you should have red flags going off in your head. This is not going to be an easy problem. So let's go ahead and read the question. The figure above shows the graph of f prime, the derivative of a twice differentiable function f. The reason why they're saying that, by the way, the reason why they're saying twice differentiable is because what they're saying is that the derivative and the second derivative both exist. So sometimes in certain questions, you need to prove that the derivative and the second derivative exist. Well, we don't even have to worry about that because it tells us in the problem that the derivative and the second derivative both exist. Normally, you have to look out for that for questions involving mean value theorem, intermediate value theorem. I don't know yet if that's going to happen with this question, but that's usually when you use the twice differentiable fact. You use it for mean value theorem or intermediate value theorem. But let's keep reading. On the interval from -3 to +4. The graph of f prime has horizontal tangents at x equals -1, x equals 1, and x equals 3. Remember, what does a horizontal tangent mean? That means at -1, +1, and +3, the graph is flat. That will probably play a role later in the problem for critical points. It says the areas of the regions bounded by the x-axis and the graph of f prime on the intervals from -2 to +1 and 1 to 4 are 9 and 12 respectively. So a very important thing to point out here is they're giving us the area from -2 to 1, so this blue area here. And they're saying that area is 9, but really it's -9 because it's below the x-axis. Like, they're really trying to be tricky here. Can't forget about that. And then they're saying the area here in red is 12, but we know that's -12 because it's below the x-axis. So that's what they're saying by this last sentence right here. You'll notice I've already said like 5 things about this question before I even get to part A. Should you be doing that? You don't have to. As a matter of fact, on the AP exam, when I got to rush through this test, I'm not giving as much of an explanation as I am right now. I'm just going through the questions. But the reason why I'm pointing this out to you is because subconsciously, even if I don't say it out loud, these are the things going through my head when I read the word twice differentiable, when I read the words horizontal tangent lines, when I read the word area is 9 and 12. So all of that's going through my head subconsciously whenever I'm reading a question like this, because I know it's going to come up. Part A, find all x coordinates at which f has a relative maximum. Give a reason for your answer. Already, the first one is incredibly difficult. I have a feeling A, B, C, and D, none of them are going to be easy, but that's fine. So forget this graph is here for a second. Literally, forget it's here. If you wanted to find a relative maximum, or a relative minimum for that matter, you're given f of x, you'd find f prime of x, you'd set f prime of x equal to 0. That would be the critical points, which are super important, which is why they're called critical points. You would then make a number line, and you'd put your critical points on your number line, and then you get like some regions where it's positive and negative or whatever. And when you get positive to negative, that's where a maximum occurs. So that's the strategy. And even though we don't have a function, we do have the first derivative. It's the graph they gave us, and we just need to find where that equals 0. I want to be very clear with you. This is not the slope. Like, if you try and find where the slope is 0 here, you will be incorrect. Why is that? Because the slope of this would be f double prime of x is the slope. So don't look at the slope. Look at the y value. So for f prime of x, any question involving f prime of x, you're going to look at the y value. And when is the y value 0? It looks like here, here, and here. So those are my points that are going to go on my number line. So first I'll say critical points at x equals -2, 1, and 4. Those are the points that are going to go on my number line. And then I'm looking for where it's positive and negative. And once again, we're looking at the y value because we want to know where f prime of x is positive and negative. So it looks like to the left of -2 it's positive, then between -2 and 1 it's negative, and then it's negative again between 1 and 4. So to the left of negative 2, we said positive. Between negative 2 and positive 1, we said negative. We said negative again here between 1 and 4. And you'll notice to the right of 4, you don't even have a graph. So don't even worry about that. We're not going to focus on that for this part of the question because they didn't give us. Like, look at this graph. There's nothing after 4. You couldn't do anything with that. So then it looks like I found my maximum because I switched from positive to negative. So there's a max at x equals negative 2. But it said give a reason for your answer. So to give a reason for my answer, that's where I have to write like a paragraph response, which is fine because I know how to do that. We would say f of x has a relative maximum, and I can abbreviate that as max, at x equals negative 2 because f prime of x equals 0 at x equals negative 2. Alternatively, by the way, you can also write that negative 2 is a critical value because that means the same thing. And one more thing I need to say, f prime of x switches sign from positive to negative at x equals negative 2. This entire thing is the answer that they want. I don't think I'm allowed to leave a single thing out of that. I at least need to say that negative 2 is a critical point and f prime of x switches sign from positive to negative at x equals negative 2. I need all of that. So that's it for part A. That was fun. Now let's go into part B. On what open intervals contained in negative 3 to positive 4 is the graph of f both concave down and decreasing? So first, we'll focus on the concave down part. Remember that concave down is where f double prime of x is less than 0, which, remember, I was given the graph f prime of x, which means we're really looking for f prime of x, the derivative. So in other words, I'm looking for where f prime of x has a negative slope. That's going to be where f double prime of x is less than 0. So going back to my graph, I just need to find where this function has a negative slope. It looks like that's going to happen here from negative 3 to negative 1, and here from positive 1 to positive 3. That's where the slope is negative. So I'm going to give my answer in interval notation because that's typically what they like. I'm going to write negative 3 to negative 1 in union with positive 1 to positive 3. There's where I'm concave down. And I also want to know where the graph is also decreasing. So remember that decreasing simply means where is f prime of x less than 0. In other words, I need to know where the y value is negative, specifically for f prime of x, because that was the graph I was given. So where is f prime of x less than 0? Let me erase some of these lines. So basically what that means is where am I negative? I am negative in this entire region right here, all the way from negative 2 to positive 4. That's where I'm decreasing because the y value is negative. So I'm going to write, again, interval notation, negative 2 to positive 4. And now I just need to find where these regions overlap. In my opinion, the best way to do that is to make a number line. So first with concave down, negative 3, negative 1, 1, and 3. So negative 3, negative 1, 1, and 3. I have these regions right here where I am satisfying that criteria. And then the other region is from negative 2 to positive 4. That's about here to positive 4 is over here. And that's going to be this region right here. And now all I need to do is say to myself, where do these overlap? It looks like they overlap here and here. So the answer is negative 2 to negative 1 in union with 1 to 3. And there's my answer. Does it say they want an explanation? Let's see. Give a reason for your answer, our favorite. So the reason why this is our answer, we would say f of x is concave down and decreasing on negative 2 to negative 1 in union with 1 to 3 because that is where, and now I'm going to reference f prime of x because that was the graph we were given. I'm going to say that's where f prime of x had a negative slope. Again, that was the concave down condition. And f prime of x was negative. That was the decreasing criteria. And so this is my whole explanation right here for that one. Pretty lengthy. I know. But when they say give a reason for your answer, that's what they're looking for. They're looking for what you did, but just in word form. And as long as you say something like this, it doesn't have to be this exact wording, you'll probably get credit. Now into part C, find the x-coordinates of all points of inflection for the graph of f. Give a reason for your answer. So first we need to remember what a point of inflection is. That is where the second derivative equals 0. It's kind of like a critical point, but for the second derivative. And you need a sign change. We're going to need a sign change for the second derivative as well. So first let's find where f double prime of x equals 0. Remember, we're only given f prime of x. So if we want to find f double prime of x, that's the slope of f prime of x. And we're looking for where the slope equals 0. Scrolling back up to my graph and erasing a lot of my lines here again. We already said where the slope is 0. It's here at -1, here at +1, and here at +3. So those are my, not points of inflection, but the points that could be the points of inflection. So f double prime of x equals 0 at x equals -1, +1, and 3. Then I make a number line here on it, -1, +1, and +3. And I need to find the regions where f double prime of x is positive and negative. Again, we're looking at the slope of f prime of x. So scrolling back to the top here, let me erase some of these circles. I would say it's a negative slope here, a positive slope there, a negative slope there, and a positive slope there. So in other words, on my number line, I'm going to put negative, positive, negative, positive, which will look like this: negative, positive, negative, positive. It looks like I have a sign change at all three of those points, because it changes from positive to negative and vice versa. So all three of those points, x equals -1, +1, and 3, are our points of inflection. I think I said critical points a minute ago. I meant points of inflection. And there's our answer for part C. Oh, we need to give a reason for our answer. I apologize. So those are the points of inflection because f double prime of x equals 0 at those points, and f double prime of x switches sign at those points, because that's what we're looking for whenever we look for points of inflection. And then finally part D, given that f of 1 equals 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. Okay, so remember, whenever you have a derivative function and you want to go back to the original function f of x, we need to look at the area, which is why we're finally going to use the areas that they gave us a while ago. So first, setting up the integral, I do want to point out the fact that f of 1 equals 3 is important. That's our starting point. Our starting point is x equals 1, y equals 3. And the reason why that's important is because when I write f of x for part D, I'm going to write f of x, my original function, is equal to my y value, which was 3, plus the integral from my bottom bound, which is the x point 1, to my top bound, which is the variable x, integral of f prime of t dt. The reason why it's prime is because we're taking the integral of a derivative because we were given the derivative. And the reason why it's t is because you have to put t, because we already used x for the bounds, and integrals pretty much say you can't have x in both the bounds and the integral itself. So you just need to choose any other letter. We just use t. That's the way we learn it, so we do it that way. And remember, the 1 comes from the fact that we're starting at x equals 1. The 3 comes from the fact that we're starting at y equals 3. And then they want us to find f of 4 and f of -2. So first we'll find f of 4. If we want that, then we just need to add the area from 1 to 4, which is -12. So then f of 4 is going to be 3 plus the integral from 1 to 4, that's where the x goes, of f prime of t dt. So in other words, it's just the area from 1 to 4 of my derivative. Again, that was -12. 3 minus 12 equals -9. That's my answer for f of 4. And then for f of -2, it's pretty tricky. That's okay, I like tricky.
It's tricky.
We have 3 plus the integral from 1 to -2 of f prime of t dt. And whenever you have your bounds flipped, what I mean by that is the higher number always needs to go on top. Whenever you don't have that, you need to flip the integral. And what that looks like is 3 minus the integral from -2 to +1 f prime of t dt. See what I did there? I switched the bounds, but you have to make the integral negative. That's the rule. And the reason why that's important is because now, looking back at the graph, the integral from -2 to +1 is -9. So that's what I'm going to put here. 3 minus -9. The two negatives will make a positive. Looks like f of -2 is going to be 12. And that's our answer for that one. And actually, that does it for this question. We answered all 4 parts. Excellent. If you do have any questions, please post them in the comments below. Thank you all for watching. I hope you have a great rest of your day, and I'll see you in the next video. Take care. Bye-bye.